you to the lecture number 2 of microwave engineering subject. In this lecture, we will see what is the microwave, what is the significance of it. Then we will discuss in broad what is frequency spectrum in detail. Okay, so let's start with the lecture. So in the previous lecture, I have asked you one question that what is the working principle of microwave oven? Okay, microwave oven is there. So which kind of principle or on which principle it operates? So that is option 1 is mutual inductance, induction heating, resistive heating, and exposure to the micro frequency. The correct answer is option number 4. 4. In the comment box, I think Aniket has given the correct answer. He has the only commented in the comment section. So I request you to all of you that please comment if you know the or you don't know the answer, but whatever you know, just comment it. Okay. Just don't keep your ideas with you. Share with us. So I will get whatever you are getting or not. What I'm trying to say. Or just Google it. You will get the answers. So this principle we'll see why how micro ovens work. We'll see in detail in the upcoming lectures. So as I told you, I will start with the microwave. That is overall frequency spectrum. Electromagnetic waves are there. So electromagnetic spectrum we are seeing. So it is start with some kind of narrow bandwidth. Here you will see a frequency, and here you will see a wavelength. Wavelength, I will tell you what exactly mean by wavelength. Wavelength and frequency, there is a relation. I will tell you in later upcoming slides what is the relation in between that one. Okay. So gamma rays which are having maximum frequency, that is 10 raised to 22. Okay, 10 raised to 22 to 10 raised to 19. Means 10 raised to 19 to 10 raised to 22. That is the gamma rays. Then X-rays, that is 10 raised to 6 to 10 raised to 19. In between that you will find X-rays. So can you tell me where we are using the X-rays? So comment box is open to you. You can comment is where we are using X-rays. X-rays, different kind of use of X-rays. Okay, you have to comment in the comment box. Then ultraviolet rays, whatever the ultraviolet rays we are having, that is 10 raised to 15 to 10 raised to 16. Okay, that is the ultraviolet rays. So we know that ultraviolet rays, the rays coming from the outer space, that is from sun, that is protected by our ozone layer, and from which we can the diseases like cancers are that can be uh, hazardous. Okay, the hazardous waves are there, so that can be rectified by the ozone layer. Okay, after that you will find the visible ray, visible spectrum. This is the visible spectrum there, and after the visible ray you will find the infrared. So we are know that infrared we are using in our remote sensors, then means TV remote, then AC remotes. Previously they are using, now RF remotes we are using. Okay, so infrared is there. So violet, that is this frequency is near about what you can say a red color. Visible ray this side ultraviolet, so you will find a violet ray, that is blue side over there. Here you will find a red side. Okay, that is, you know that Vibhav Gauri is there, seven color spectrum is there. Okay, so red color is what you can say, it is having more frequency, or what you can say more wavelength itself. So it is more visible, so that's why in the red signal we are seeing red color we are using instead of other colors, the infrared spectrum. Then here you will find the microwaves, exactly microwaves 1 gigahertz to near about 30 gigahertz you will find, that is the microwave frequency range. Okay, then you will find a television. Here you will find television, then AM radios, then long radios, long wave, whatever the uh, waves are there, that is used for satellite communication and all, that we are using over here. Okay, so this is all about the spectrum. It is not particular one, electromagnetic spectrum. I will discuss in the another slide that again how it is works and what are the uses of electromagnetic spectrum. This is the broader electromagnetic spectrum. So this is wavelength in meters. So here wavelength means I have shown a size of, that is wavelength is nothing but 10 raised to 1 meter. Then this is the size like a our tennis ball. This is a personal point in itself. Like this one, this is small cell. Okay, so wavelength I have compared with the different objects we are having. So whatever the wavelength, if you are increasing the wavelength, so that are nothing but the radios, like your antenna for communication itself. Okay, AM radio you are having like this one. Then in between this, you will find a microwave. We can use in micro one itself. In the very useful application of this is nothing but the radar. Okay, you know that radar is nothing but the full form of radar is ranging and detection. Okay, so we are using this radar in navigation purpose. That is nothing but if you want to find out the target of the enemy's aeroplane, then we are using radar for different kind of application, like a portable radar is used for finding the speed of any vehicle. Okay, normally you have seen in the movie that when policeman is standing over there and he is having one portable device, he is switching that one, and if some bike is passing or car is passing from that one, automatically speed of that car will be detected. Okay, so like that one, that is the what you can say. I have seen over here. I have shown you over here. That is nothing but the 10 raised to 3 wavelength in meter means 1 kilometer size of wavelength is there. That are nothing but the radio waves that. Okay, radio waves that. Here, if you are decreasing the size, then the wavelength, then it is in the gamma rays. So if I want to compare these two means wavelength and the energy of the everything. So as we are increasing the wavelength, we are increasing the wavelength, so its energy will be decreasing. And if it is having lower wavelength, then energy will be higher. Okay, energy will be higher. So here I have shown energy in one photon. Okay, energy of one photon, just one photon, 10 raised to 19 electron volt. Electron volt is the energy, sorry, unit of energy. Okay, so in just one photon, can you imagine the energy of gamma rays? That is 10 raised to 6. The gamma ray radiation is very hazardous. Okay, that's why means you cannot survive by using gamma rays and all that. So gamma rays we are using a lot of devices also for diagnosing of cancer and all that, but the specific use of that is nothing but the to destroy the cancerous cells, right? So this is the relation in between. I have shown you the wavelength, then as compared to wavelength in size, then what are the common names are there, like this one infrared is there, then ultraviolet is there, then soft x-rays are there, then hard x-rays are there, then gamma rays is there. Okay, so we'll go to the next slide. Okay, so this is the wavelength. This peak to this place, whatever this is called as wavelength. So we know that wavelength is in nothing but f. Sorry, we know that frequency is equal to c, that is the speed of light divided by wavelength. This is a wavelength. So if I want to calculate this one, so the lambda is equal to c by f. That is nothing. C is nothing but the speed of light. That is nothing but 3 into 10 raised to 8 meter per second is the speed of light divided by, if frequency I am putting, I will get the lambda. That is nothing but this one. So if I know that from this one here, if wavelength is more one, then what will happen with the energy? You see, if wavelength is more one, this is the wavelength, it is more one, then energy is lesser one. So energy is lesser one in this one. You will find lesser energy over here. And if the wavelength is more, that is frequency is more, then we are getting maximum energy from this one. So microwave frequency range is 1 to 38 gigahertz. So if I'm calculating from this one, if I'm putting the frequency is equal to 1 gigahertz, so lambda is equal to what will happen? Lambda is equal to f by c. So sorry, c by f, that is the 3 into 10 raised to minus 3, sorry, 3 into 10 raised to 18 meter per second divided by whatever the frequency is there, 1 gigahertz. So I will get 30 centimeter is the wavelength to 1 centimeter, from that is nothing but 30 centimeter to 1 centimeter. So maximum frequency, maximum energy, lower frequency will get a lower energy. Okay, so micro frequency, whatever this, that is divided into this part. Okay, so 1 to 2 you will find some real band, then 2 to 3 you will find S band. Likewise the frequency spectrum is divided. So 122 in between it, that is nothing but the L band. We are saying that 1.4 to 1.6 gigahertz, 1.4 to 1.6 gigahertz. So this is nothing but the mobile satellite services. So whatever you are using for voice and data communication of by using mobile, that is nothing but the L band. We are using the L band frequency. Keep in mind, whatever the SIM cards we are having and whatever the range we are getting from this is in between 1.4 to 1.6 gigahertz. That is nothing but the mobile satellite service. That is MSS, narrowband voice and data. Second is S band is nothing but a 2.2 to 2.6 gigahertz. 2.2 to 2.6 gigahertz. So now concentrate on this one. Whatever the frequency I have seen in different book or different references, you will find a different frequency of this one. That is nothing but in some book you are getting 300 megahertz also. Okay, 300 megahertz. That is nothing but a zero point 0.3 gigahertz to 30 gigahertz is the range of this. Okay, so yes, man, 2.2 to 2.6 gigahertz. So that is nothing but the digital audio radio services. Whatever the DARA services are there that are in the S band itself. Then C band is nothing but the 4.4 to 7 gigahertz. That is the fixed satellite services shared with the terrestrial. So whatever the satellite phones are there in the different terrestrial that are using, that is nothing but the 4 point C band, that is 4 to 7. These are not for common people they are giving. Okay, those satellite phones are there, whatever they using. Then X band, that is nothing but the 8 to 10 gigahertz, that is nothing but the fixed satellite services that are for government exclusive use. Is whatever the government is using, that is FSS frequencies they are using. Then KU band is 11.7 to 14.5 gigahertz. So that is the broadband services not shared with the terrestrial. Okay, so broadband services are there, but terrestrial they are not sharing. Then KU band, again take KU band, there are two bands are there. So 12.2 to 18.8 gigahertz. So broadband satellite services. So whatever the DTS services we are getting, so they are coming into KU band. That is nothing but a 12.2 to 18.8 gigahertz. If you are using some data satellite or DTS service, direct to home service, so if you are scanning the frequency, you will get the frequency range in between these two. Then KA band. KA band is in between 20 to 30 gigahertz. That is the broadband service not shared with the terrestrial. Okay, so we have seen the frequency spectrum in detail. What is the spectrum detail? Energy and wavelength. What is that? Then where microwave exists in between 1 gigahertz to 30 gigahertz. So in between this, our micro frequencies exist. So where is the location of infrared? Where is the location of ultraviolet? Where is the location of soft and hard X-ray? Then gamma rays, some kind of air, and whatever the radios are there. We have seen in this one. So I'm stopping over here. So I have one question. So please give me the answer of that question in the comment box. Okay. So thank you very much.